Hi Java programmers, welcome back. In this video, I'm going to go through what an exception is, what are the two different types of exceptions, and some examples of such exceptions. I already have a main class coded up with a main method, and in the main method, I'm going to start off with what is an exception. So an exception is an event that occurs during runtime that disrupts the normal program execution or instruction flow. So I'll type that up here. There are two types of exceptions in Java. So the first one is called an unchecked exception. And I'm going to show you an example of an unchecked exception here. An unchecked exception comes in two flavors: errors and runtime exceptions. The other type of exception is checked. So if we have an unchecked exception, we have a checked exception as well. An example of a checked exception would be an exception that you have to handle or acknowledge. And I'm going to make a little note here. By handle, I mean try catch block, and by acknowledge, this is also called specifying. I'm talking about the throws keyword on the method header. And I'll do examples of unchecked and checked exceptions, and I'll show you handling versus acknowledging. All right, so let's start with an unchecked exception. So an example of an error would be, say, a out-of-memory error or a stack overflow or a buffer overflow. Errors are unchecked exceptions that crash your program and there's nothing you can do about it. If the operating system is going to kill your program, the operating system is going to kill your program. So an error is not actually an exception that we can handle or recover from. So no Java code for us to write related to handling errors. Runtime exceptions, on the other hand, those are exceptions that we can anticipate and in many cases should handle. So let me give you an example of an unchecked runtime exception. So this is my favorite example. It's very easy. We see it oftentimes when learning to program. Let's say I have some variable, it's an integer, and perhaps through some logic somewhere, something happened where I'm dividing by 0. Now, why is dividing by 0 an unchecked exception instead of a checked exception? So here's an indicator. This compiles. Okay, I'm not going to get a compiler error if I try to run int x gets 5 divided by 0. Now, IntelliJ, it's got some advanced features here, and it's letting me know I've got a problem with this via a warning, but let's say bad practice, I'm going to ignore this warning and I'm going to run this. So down here in my console, I get my output here. It says exception in thread main, java.lang.arithmeticException, divide by 0. And it tells me where this occurred. The capital M main class, main method, line 13. I could click on this and it would bring me right to this line, just like that, which is really nice. This is called the stack trace. Now, the stack trace shows up in red in my particular operating system, IntelliJ, Java install, etc. Might not be red on your machine, but it's showing up in red here because this is being written to something called standard error. Every time a program is created, there's 3 file descriptors that are open. Standard in, which gets input from the keyboard, standard out, which writes to the console, and standard error, which also writes to the console. So standard error writes to the console in red text here. Now, right down here it says process finished with exit code 1. Okay, I want to emphasize that this exit code is 1, not 0. So 0 is reserved for executed and terminated gracefully. Nothing wrong happened. Anything other than 1 indicates some sort of error code. So the fact that I have a 1 here means that my program crashed. It did not gracefully terminate. So let's surround this with a try catch. So I'm going to try this code, and I'm going to catch that arithmetic exception if my line 14 throws it. So arithmetic exception E, and with E, I can call e.print stack trace, which if this line fails, okay, it throws an arithmetic exception, my catch block will execute, and I'm going to still print out the same stack trace here, but I want to show you a really important distinction. Okay, watch here, exit code 1, I run again. Okay, I get similar output here, and it says process finished with exit code 0. So I want to emphasize that with this try catch block, when I divide by 0, my program does not crash. In fact, I'm going to put a line here where I'm going to say something like program continues ... so that you can see this line of code is going to be executed because we're handling the exception. We're not allowing it to crash our program. Here it says program continues. Run it a couple more times, and it looks good. Exit code 0. This is an example of an unchecked runtime exception. Let's move on to doing an example of a checked exception. So you're going to see right now a very, very clear way to figure out in something like IntelliJ, or even if you're not using IntelliJ, just compiling your code, whether you have an unchecked or a checked exception. So let's say I'm going to try and read from a file. I'll use scanner to do this. You will need to import java.util.scanner. All right, I'm going to try and open an input stream to read from a file that doesn't exist. So I'll do inFile is assigned new scanner to scan from a new file, and this file shall be called dne.txt. dne here is just short for does not exist. And I'll import java.io.file in order to access file. I do have to put file around here, otherwise the scanner is going to try and scan the string, not open a file and then scan the contents of the file. So now I have a problem. My code doesn't compile. So here I'm mentioning that IntelliJ is giving me a compiler error before I even try to compile it. It says unhandled exception, java.io.FileNotFoundException. And if I try and run it, I also see this compiler error here. Java.io.FileNotFoundException must be caught or declared to be thrown. Okay, so there's our two options right here, caught or declared to be thrown. These are the two that I specified up here. So let me show you the latter, declared to be thrown. I could say, I'm not going to handle in this method, I'm not going to try catch this checked exception, FileNotFoundException. Instead, I'm going to require whatever code calls this method to handle it. So kind of like delegating or propagating responsibility, saying, I'm not going to do it here, let someone else deal with it. And that someone else is whatever code calls main. Okay, or if you're in a different method, whatever code calls that method. So I would put throws FileNotFoundException up here on my method header, and now that error goes away. Run this. Okay, it crashes my program. Right here, exit code 1, this was not a graceful termination of my program. So I'll do this. Just comment this out so that it's here for record keeping. And let's say I move all of this code into some method called simply openFile. All right, just to show you that example again, my code's not compiling. Let's say, okay, I'm not going to handle the FileNotFoundException in OpenFile. I'll require whatever code calls OpenFile to handle the exception. So did you see that? The error moved from this line to this line. Now it's the responsibility of the calling code, which is in main, to handle the exception. Okay, so that's the second option I showed here. Adding throws on the method header. I'll also take this out here because this is not the approach that we're going to take to solve this problem. In many cases, though, this is the approach, especially if you're, say, writing a library or a framework that is intended for other programmers to use, then you might require that the other programmer handles the exception so that they can do appropriate actions if the exception is thrown. And that's essentially what the scanner constructor is doing, right? Scanner is throwing an exception that it's not handling. So it's requiring us, the calling code, to handle it. And you can actually see I have the documentation showing right here for scanner, and it says public scanner java file source throws java.io.FileNotFoundException. So there is an example in the Java source code, the Java framework, where there's a constructor here that throws a FileNotFoundException and requires the calling code to handle with a try-catch block or further propagate by throwing that FileNotFoundException. So there's an example of this in action. All right, so the approach that we're going to use is not to just keep throwing this. We want to write robust code here that's going to handle it. So I am going to add a try-catch, and I'm going to catch that FileNotFoundException. So I've got E here again. E is actually a reference to a FileNotFoundException object. And I could do e.print stack trace again if I want, but this time let's just show a message to our user saying something like the file was not found. That way we don't get that red text showing up. This will be written to system.out, which is an output stream for the file descriptor standard out. Exit code 0, so my program is gracefully executing and terminating, and it says the file was not found, instead of showing the red text like we did for our unchecked runtime exception. So this looks good. One more thing that I want to show you while we're here is you may often see a finally clause after a try catch. So finally is pretty neat. It executes no matter what happens in the try. So that would be success or failure. It doesn't matter. If this succeeds, finally will execute. If this fails, then catch will execute, then finally will execute. So I'm going to put in here hello from finally. And there it is. Now, let's say that this file actually does exist. Okay, so I'm going to head over to Exception Fun. I'm going to go New File, and I'll put in something here like words.txt. Just put a few words in here. Hello, goodbye. So let's say I now want to open words.txt. I do not see the file was not found because it was found, and I see hello from finally. So even on success, I'm going to see hello from finally because finally executes no matter what happens in the try. Put a little statement in so you can see that we will see here because this doesn't fail. Words.txt does actually exist here. And I'll put this back to dne.txt. We see that here will not show, the file was not found will show, and still hello from finally will show. I have one more example that I want to show you related to exceptions. It's a really great example of finally. think I'll define another method. So I'll say get integer from user. Let's define this method here. When first learning to program, you often live in happy user input land where when we need an integer from the user, we get an integer. We don't get, say, the string hello. Or if we need an integer in the range 5 through 10, we get an integer in the range 5 through 10. But let's say we don't live in happy user input land anymore, which is how real-world applications have to consider handling user input. So let's say we need, I'll put this in all capitalized, we need an integer from the user. Perhaps we're going to use it to declare the size of an array. It needs to be an integer. So let's prompt the user. We'll say, please enter an integer or else. A little threatening there, but that's okay. So I'm going to have a scanner. I'll call it KB, it's new scanner, and it's going to read from system.in, which is an input stream tied to that standard in file descriptor I was talking about earlier. So I'm going to get an integer. I'll do int, my int gets kb.nextInt. I'm going to hover over kb.nextInt here. Okay, it scans the next token of the input as an int, and invocation method of the form nextInt behaves in exactly the same way as the invocation of nextInt radix, where radix is the default radix of this scanner. Okay, returns an int, scan from the input, great. And right here it says throws. Throws java.util.InputMismatchException if the next token does not match the integer regular expression or is out of range. Okay, so look, there's actually two other exceptions that nextInt can throw. So are these three exceptions checked or unchecked exceptions? These are actually unchecked exceptions because my code compiles. I could run this, and it's prompting me for an integer. I'll enter in 5, exit code 0. So I'm going to make a note here. Throws unchecked exceptions. I'm going to run this again. 5, my int 5, great. Now what happens when I enter in a string? This is not an integer. Okay, my program crashes. It says exception thread main java.util.InputMismatchException, which is what we saw in the documentation that kb.nextInt will show if the token in the buffer doesn't match the integer regular expression. Fantastic. So we have an example of an unchecked exception. Let's surround this code with a try catch. Okay, we need to try to get an integer, and if we don't, we should catch this exception. I'm going to actually move this declaration up here, and then I will try this one line of code that crashes my program, and I'm going to catch that input mismatch exception. I'll tell the user something like, hey, that's not an integer. Very upset that they didn't follow my directions. Enter in hi, exit code 0. Great, so now if they don't enter an integer, my program isn't crashing. I want to take this one step further though, and let's say I really need an integer. My program shouldn't crash just because I don't get what I need from the user, right? I need to communicate with the user saying, hey, that's not an integer, and I need to reprompt them, right? I want to write more robust code than just giving up when I don't get what I want. So I'm going to say, hey, that's not an integer, try again, which means I need to put this in a loop so that it keeps prompting the user until this is successful. So I'm going to have a Boolean called valid, and in my do while loop, which is a really nice loop for input validation, which is what we have here, I'm going to keep prompting until they give me a valid integer. So here's the logic behind how I'm going to use the Boolean valid. I'm going to always assume good input until proven otherwise. And where am I proven otherwise? That's in the catch right here. If they don't give me an integer, this line is going to throw an input mismatch exception. I'm going to catch that exception. I'm going to tell them, hey, that's not an integer, try again. And I'm going to set valid to be false so that not valid, not false is true. This Boolean condition evaluates to true, and they are stuck in this do while loop, this input validation loop, and we're going to go through the whole thing again. Let's assume they give me good input again, try and get the input. They give me bad input again. I'm going to tell them, set valid to false, not false is true, up again. Only when this is successful will valid not be set to false, and they'll get out of this loop. So here, let's do this. I'll move this outside of my loop. So I successfully print out my int when I get an integer. Let's try it. So I'm going to enter in hi, and it looks like I have an infinite loop. Why would I have an infinite loop? If I enter in hi, I'm going to set valid to false and try again. So let me kill this and explain why I have an infinite loop. I'll explain this. Let's do it right here. So on failure to get an int from next int, whatever the user entered is still in the buffer, in the input buffer. Okay, so if I enter in hi, I'll show you what the buffer looks like. Hi, I press enter, that's going to be a new line character in the buffer. kb.nextInt goes to the buffer, tries to read an integer, looks and says, that's not an integer, I can't remove that from the buffer, so it leaves hi new line character in the buffer. So what's the solution? I need to flush the buffer. I need to flush the buffer. So I could do that here in catch. I could go kb.nextLine. This would flush the buffer. This is going to remove everything, including the new line character, before a new line character. So this would be removed from the buffer. I'm not storing it anywhere. I don't need it. But this is actually a really great application of finally. I'm going to put this in a finally clause. And here's why. Remember, finally executes on success and on failure from try. So if this is a failure, then I know that string and that new line character is still in the buffer, remove it. But if this succeeds, why do I need to flush the buffer? And here's why. Let's say the buffer has 5 new line character, right? I'm actually going to give the program what it wants. I'm going to give it an integer. I type 5, I press enter. That enter is going to be stored in the buffer as a new line character. kb.nextInt is going to go look at the input buffer, see if there's an integer there. There is. It's going to grab out the 5, but leave the new line character. So later in my code, say somewhere down here, if I'm going to be reading from the input buffer, right, standard in, using system.in, I've got this new line character sitting around, and that might cause me a bug later. So I want to do a little cleanup, right? I should flush the buffer so that when this program finishes using KB, which is tied to system.in, the system.in buffer is left nice and clean. Okay, so kb.nextLine and finally on success or failure is going to clear out the buffer. It'll make sure that our infinite loop goes away for bad input, and on good input, it's going to make sure our buffer is cleared for the next time in this program we try to go read something from the buffer. We don't have any odd behavior. Let's run this now. I enter in hi, not an infinite loop, this looks good. Hey, that's not an integer, try again. Bye, just a bunch of garbage, I cannot get out of here. Type 5, still can't get out of here. Then I enter an integer and I'm able to get out of here. So we went through several examples of different types of exceptions, checked and unchecked, try catch, and the optional finally clause here. And this last example served as a reason why you might use finally. Anytime you got to clean up some resources on success or failure, do it in finally. It's a great spot for it. Hopefully you're feeling more comfortable with exceptions. These notes up here are really helpful to review now that I'm done going through the examples. Thank you for watching.